Okay, so previous video, not my best work. I think reason being is that that problem was written not to intend to solve it all out, but just to verify the solution and to take that solution and just plug in to get the constant. So they didn't want you to do all that anti-differentiating and separating, but I was using that example and I'm trying to build on it. So this example is intended to be separated and just straight up solved, and they say find the general solution. So that means, what does that mean? General solution means plus C is okay. Right? So I think we'll do a lot better with this problem because it's intended to be separated and solved like I was doing on the last problem. That was, I bit off a little more than I could chew there, I guess. So let's talk about it. I guess I would divide this first because I want dy dx alone. So let's just kind of talk about that real quick. Dy dx alone, right? Separate. I'm just going to be really quick here. The x's and the y's, right? Anti-derive. And then for, this is optional, find C. We're always needing to solve for y. And that step can either go here or it can go here. So that's your choice. And finding C is optional depending on whether they're asking for a general solution or the particular. So let's do it. So what we want to do is get dy dx alone. So let's kind of color code here. Dy dx alone. I'm going to check it off. I'm going to say we did it. Dy over dx equals xy over x squared plus 4. Let's not lose that. Okay. That's no problem. Now we go to the next step. Separate the x's from the y's. Well, the only thing is that I need this dx over here, so I'm going to multiply it over. And I need this y over here, so I'm going to divide it over. So I'm going to put a divide by y here, and that's now gone. So I divided both sides by y, I multiplied both sides by dx in a way, and I have accomplished step 2. So it's getting a little messy, so I'll rewrite dy over y, whoops, dy over y equals x over x squared plus 4 dx. And now we are to anti-derive both sides. So if we're anti-deriving both sides, where are we at? Well, we want an integral, integrate. So this one has to be kind of rock solid. It is ln of the absolute value of y. Done. Now this one here, the second problem, you might have a little trouble with. But hopefully you're up for the challenge. So this whole step could be a little bit longer, because what we're going to have to do is we're going to have to solve this problem. We're going to need to do a u substitution. The derivative is the top, and the original, I guess you could say, is the bottom. Okay, just erase that. Okay, so our u substitution, and you got to be solid on this, is going to be really this right here is the integral of, let's see, 1/2, I'm taking that out, du, so that's x dx right there, over u. So this is going to anti-derive to 1/2 ln of the absolute value of u plus c. So I'm going to write down here 1/2 ln of the absolute value of, and I'm going to put in u, x squared plus 4 plus c. And we have solved 3. Now they say it's a general solution, so we don't need to find c, so we're going to scratch that out. We're not going to find c at this point. We're just going to solve this for y. So let's ignore everything else. If you need to pause or rewind, go ahead, but we're just going to go here. So we want to solve it for y. I am going to take this 1/2 and put it up into the, see, they're going to love to do that a lot, actually. So what you have here is, I guess, ln of the square root of that, right? So what you have is you have to e both sides, exponentiate. So just be aware, e to the. I don't know if that caret's good or not, but we'll figure it out. Absolute value of y is equal to, here's that weird thing, c and then I have times, I guess what I have is technically square root of the absolute value of x squared plus 4. That's kind of where I'm at. Clearly, that square roots domain is only going to be the positive numbers anyway, so this absolute value is kind of unnecessary. Because if we, plus the x squared is positive anyways, that's going to come out positive, so we can kind of drop these. You can kind of drop these for that reason. Because what's happening is you're square rooting something, it's got to be a positive inside the square root. It's an x squared anyway, so that's positive, and then you're adding 4 to it, so that's positive, so we didn't really need that absolute value. And that's what a lot of these problems are going to do. They're going to kind of save you some struggle, I guess you could say, from that. So I guess what I would say is y is equal to, and I want to say plus or minus c root x squared plus 4. There's actually 2 solutions, and we don't know which one to choose because we don't know if y comes out positive or negative. And if we knew y comes out positive, we would just write c square root of x squared plus 4, but we don't know what y's value is. If we knew y come out negative, we would just go with that as well. We would be good to go. But we don't, so that's where we're at. So I guess the general solution is just that. C and then square root of, right? And yeah, it could be plus or minus. The book doesn't actually have that, but I'm actually pretty comfortable with that because the y could be either of those things. Okay. All right, let's move on. Let's try to get some more done here. So now you're trying this one. So let's see. You try this problem. It's a combination of the last 2 examples, so one from the other video. They're telling you to find the particular solution that satisfies the initial condition. So what I'm saying is it's a combination of the last 2 examples in the sense that the differential equation is not horrible. It's like the one we just solved on the previous page. But and now they're adding the initial condition in. So if they're adding the initial condition in, okay, they're saying you need to find C. Find C also. That's what they're telling you. So you need to also find C, which is what we did in that first example. It was just a very much a mess. So hopefully this one won't be quite as messy. It'll go a little smoother, but that's where we're at. So take a second, pause the video, give this a shot. You can look up the answer in the back, of course. All right, so I'm hoping that went well. We're going to do one more, and I think we have the time for it because we're on the second video now. So they're giving us the initial condition. This is kind of just what you did before. It looks like this is a tough one. I mean, just looking at it, it looks ugly, right? So what I'm seeing is I don't see, usually step 1 is dy dx alone, right? But dy dx are already kind of like separated out. So I can't really do that. I think I'm just going to try to get all the x's, right, over here, over to this side. And then I'm just going to leave all the y's where they are, hopefully. So let's try it. Geez. I can't think of a great option. I think the first thing I'm going to do is subtract x, y, dx. Unfortunately, I didn't want to move that y, but I kind of was left with no choice. So minus x, y, dx. Okay, and that equals, and that's equal to e to the negative x squared, y squared minus 1. I'm going to get that y over to where it belongs by dividing it. And I'm going to get e to the x squared where it belongs by dividing it. E to the negative x squared. E to the negative x squared. And that's that. Okay, so what do we have? What do we have? We have the following. We have y squared minus 1. Oops, I left out a dy here, by the way. That. Dy is over here, all over y, equal to negative x over e to the negative x squared dx. Okay? So we just pulled the dx to the side and kind of dealt with it that way. And now we're at a point where we could antiderive. What does this mean? This means that the point is 0, 1. That's the x and the y. So let's go through this and see what we can do. Well, we could plug in now. No, we can't plug in now. We can't plug in until we integrate. So we got to integrate. So my apologies. Okay, so here, two fractions, y squared over y. You see why we did so many of these? These skills are important. Okay, and here, I think a u substitution. I don't really know what else to say. So here, this guy has to all be u substitution. So u is equal to negative x squared du is equal to negative 2x dx. I didn't really need, I'm going to pull that negative out front right now. I didn't really need the negative 2, so I'm going to divide that. So what I think I have is I have this negative 1/2 that's going to be in the front, but there's also a negative right here. So I'm going to have a positive 1/2, okay? And then I'm going to have du over e to the u. So what is that? I guess that's e to the negative u. That's 1/2 e to the negative u du. Interesting. So I think what I'm realizing is that I could have done something smart here. I didn't do it, but I could have. I could have moved this up instead of making it right here. Instead of leaving this alone, I could have moved it up here, make it e to the x squared. And that would be our new problem to solve. And that would make our life a little bit easier, but I didn't do that, unfortunately. And so now I need to think about what e to the negative u is going to antiderive to, right? So e to the negative u, I guess, would antiderive to negative e to the negative u. Does that make sense? I mean, e to the negative u is going to derive to e to the negative u times negative 1. So negative e to the negative u, this should derive, if we derive it, it should be negative e to the negative u times the chain rule of negative 1. So this is kind of a chain rule in our head in a sense. We are thinking that this antiderivative is negative e to the negative u. So I'm going to leave it as this plus c, and that's going to equal to our left side. We'll bring that left side back in a second. I think I'm just getting a little short on time here, so I'm trying to wrap it up. So I've got negative 1/2 e to the negative, what was u? U was negative x squared, so I guess it's really just x squared plus c. And here I have, well, I didn't derive this yet. I have, really that's y, so that's going to be y squared over 2, because that simplifies to y, right? So y squared over 2. This is ln of the absolute value of y. So I have y squared over 2 minus ln of the absolute value of y equals. Okay? That is where we are at. Let's try to see if we can get to the end of this in the next minute or so. So we need to use the point 0, 1. I'm going to attempt to plug in now. So I'm going to plug in 0, 1 right now for x and y. I'm going to see if I can get through this. So the ln of the absolute value of y, well, y is positive, so we really just have minus ln of 1. And it doesn't really need to be absolute value anymore, because y is positive and we're not going to use the absolute value, so to speak. And this is 1/2. And this is now negative 1/2. That's e to the 0, so that's 1 plus c. ln of 1 is 0, so I have 1/2 equals negative 1/2 plus c. So I have c equals 1. And I guess my solution, which is not solved for y, which it should be. I do want to make that perfectly clear. This should be solved for y, but it is not. Is this. But in the interest of time, I'm not going to solve for y, because that's it. I'm out of time. So we're going to stop there. Let's see. Yeah, I guess that's good. I think it would be good for you to try this problem still, so keep that in mind. But otherwise, you are good to go. So that's enough for tonight. So the 2 videos, and then we're going to try this problem. So let me just kind of make that clear here. Skip this for now, and then you try this problem, and that is all. Okay, so this should be doable, just change up the variables a little bit. I think there might be some confusion because there's a k here for a constant. It's a little weird, but I think you're going to be able to get it. And that is it. I got to stop here. Normally we would solve for y, but we don't have the time.